Welcome to another edition of Teach the Geek interviews. My name is Neil Thompson. I'm the founder of Teach the Geek. It's an online platform for science and engineering professionals. Consider checking it out at teachthegeek.com. Again, that's teachthegeek.com. Today, my guest is Dr. Jon Wade. He's a systems engineer who's worked in industry and academia. Currently, he's in the latter. Dr. Wade is also an expert in ethical sustainability. I wanted to speak with him specifically because I have no clue what ethical sustainability is. I also want to learn more about his journey in systems engineering and the moment he realized that public speaking could be of use to him. Welcome to Teach the Geek interviews, Dr. Wade.
Thank you, Neil. It's a pleasure to be here.
From the bit of research I did on you, I saw that you got a degree in electrical engineering and computer science. Where did that interest come from?
Well, I'm one of those strange people that always knew what they wanted to do. So I think it was probably when I was about 5 years old, I was interested in electrical things. They were kind of like magic to me. And so I was one of those people that would tear everything apart and sometimes be able to put it back together and it would still work. So it was just an interest that I've always had, and I just sort of followed it, through my professional career.
I saw you didn't just stop with a bachelor's. You got a master's and a PhD too. You went for the whole enchilada. What was the motivation to get all the degrees?
I couldn't quit, I guess, this program is for geeks. And so I raised my hand, I'm a geek. I just really enjoyed learning this stuff. So, the fact was I was able to get a fellowship, so I didn't have to pay for the graduate education. Which enabled me to sort of go on. And I was just able to continue to learn more about the things that I was interested in. So at the time I was interested in semiconductor physics. So that's kind of where I went. And then on my research, I was working on systems. So I was kind of going in two different directions. One side academically was getting to the smaller. And then, in terms of my engineering side, was going to the sort of the larger and the larger. But it wasn't something that you do for economic sense, because it's a lot of years with you're not making any money, but intellectually it was really joyful for me.
All right, so you get 3 degrees and now it's time to get a job. You mentioned that you did systems engineering type of work in graduate school. I only learned about systems engineering maybe a couple of years ago. I'd never even heard of the field before. So if you were to describe what systems engineering is, how would you describe it?
So I would describe it as whatever it takes to make a system successful. And by successful, I mean successful in respect that it satisfies people's needs, that it creates value, that it satisfies all the different stakeholders that are affected by the system. And I have to tell you that I didn't know what systems engineering was, and didn't even know, had never put those words together when I was doing this work. And it really wasn't until later in my career, when I moved back into academia, that I started thinking about systems engineering as a discipline. It had been something I had done, but it wasn't something that I had naturally studied.
Okay, I got you. So when you finished your PhD and it was time to go out there and start making that money, did you go out there to be a systems engineer, or is it something that you came to at some point?
So I went out, I wanted to build the most complicated things, most complex things that one could build, which at that time was supercomputers. So I went in, I wanted to develop supercomputers, and there was a company just down the street and some people that I knew there, a company called Thinking Machines, a wonderful company. Our motto was we wanted to build a computer that would be proud of us. Never quite got there, but we built some amazing machines. And, it was about systems, but I didn't think of it from an academic perspective. The challenge was, how are we going to build a machine like this that's going to do all these amazing things with the amount of people that we have, the amount of time that we have, and the amount of money that we have. And so it's not only the machine that you're building that you have to think about, but you have to think about how are you actually going to build those machines. And so it's sort of both sides of the problem. And I think that's sort of where the systems engineering comes in. It isn't just looking at the technical aspect of the thing you're trying to build, but it's also looking at how you're going to do it with the people, the organization, and so on that you actually have. And what is the machine actually going to do? So those are open questions. You're not going to find an equation for those sorts of things. And those are the kinds of things I think that people who are working systems systems engineers, they actually like those kinds of problems.
Gotcha. You know, for most of the people that I know that get PhDs, Dr. Wade, they end up, well, at least the goal from getting the PhD was to work in academia as a professor. But it sounds like you went and actually got a job at a company, at least initially. Was it ever the plan to go back to academia?
No, it was never the plan. And, you know, so I worked in industry developing computer systems, first at Thinking Machines, then a company called Sun Microsystems. I did a little startup in portable power generation for a couple of years and did some simulations and actually showed that it wasn't going to achieve what we wanted it to achieve. It was, you know, unlike Volkswagen, where they programmed their engines to be either clean, you know, or efficient. We didn't want to go that way, and so we sort of closed that down. And then I spent a few years as an executive vice president at what was then the world's largest slot machine and casino management company, which was a bit of a different gig. And after some time of that, I decided, you know, that, you know, making the world have better casinos wasn't sort of my life calling. And so that brought me back to academia, where I wanted to make a difference and really feel that most of the challenging problems that we have are systems problems. They're not going to be solved by technology, or certainly not by technology alone. And we don't really have enough people who understand systems. So I thought education would be the best place for me to go. And so I went to a place called Stevens Institute in Hoboken, New Jersey, and became a professor of systems engineering. And eventually I was the associate dean of research. I was the department chair in systems and software engineering, and then chief technology officer in the systems engineering research center. So that was what brought me back to academia, was really to make a difference. So it wasn't, you know, to rise to power or to make money or those sorts of things, but really apply my expertise in areas that could have the most impact.
Another thing that, at least for people that get PhDs in the STEM fields, I get the sense that once you get that degree, you kind of, especially if you're going into industry, you kind of get pigeonholed into certain roles. So for instance, you know, you get a degree, a PhD in engineering, they're going to put you in product development or R&D at a company. Is that something that you experience? But even if you did, you were able to find your way into other things. I mean, you mentioned you worked for a company that's related to casinos. How are you able to, I guess, avoid that pigeonholing?
So I guess I was pigeonholed in the sense that all the positions I had were technical positions. So I was, you know, always in the engineering organization. So I didn't go into the other organizations, and frankly, didn't really want to. You know, I'm interested in engineering. I'm interested in creating things, building new things. I mean, to me, that's what is exciting. So although I wasn't pigeonholed with respect to being purely technical, you know, I certainly didn't stray far afield from, you know, sort of my technical roots. So yeah, I really think it's, you know, do you want to go into the management track or do you want to stay on sort of the technical track? And most of the places I went to, you know, sort of started out with startups and Silicon Valley type of companies. The technical people are on both sides of the tracks, you know, in those types of companies. They're not traditional companies. They're very quick moving types of companies. And I think having a PhD in those kinds of companies is not going to cause you to be pigeonholed unless you want to be pigeonholed. I mean, there are people who are really quite happy being in their lab working alone. Thank you. And that's where they'll end up. But I think that if you're interested in doing more and getting more involved in, you know, on the managerial side, there are opportunities for that. And you'll quite often find that in technical companies that there are PhDs who have pretty high ranking positions. Generally, they're not the CEO, but certainly sometimes they are.
Yeah, and you know, I think another thing when you were talking, Dr. Wade, I thought about is your varied history and how often it might be difficult to move from industry to industry. I mean, I used to work with a number of project managers, and they would say that you could be a project manager for any industry, but then you can go to and actually ask somebody who works in a company, and they'd say, well, we actually want a project manager that has experience within our particular industry. So they don't want someone that, for instance, if you're working at medical device company, they want someone with medical device experience as opposed to a project manager with construction experience. How are you able to navigate just moving within industries?
That's a really good question. And some industries are more open and other industries are more closed. So there are industries where if you haven't been there for 20 years, you're simply not going to be able to get those positions. I mean, they're not going to allow it. I was fortunate in the sense that what I worked on tended to be, electrical engineering and computer science types of things. And if you think about it today, what things don't have computers in them, what things don't have software, what things, and AI and machine learning are becoming ubiquitous as well. And so if you're working in one of those spaces, you can go just about anywhere you want, because almost every system we have are those kinds of systems. And so with that kind of a background, I was able to sort of move pretty easily, from one industry, to the next. I think that if you were, for example, somebody who is a mechanical engineer who had only spent time developing inkjet technology or airplane wings or things like that, it would be a much more difficult move. But I think if you are in electrical engineering, computer science, software, AI, machine learning, data sciences, and those sorts of things, I think you can move pretty fluidly from place to place.
Gotcha. I mentioned in the intro, Dr. Wade, that you have an interest in ethical sustainability, and I also mentioned that I have no clue what it means. So now I'm interested to hear from you. What is ethical sustainability?
So it's another great question. When we talk about sustainability, people tend to think about the environment, but there's really been, sort of three accepted pillars of sustainability: environmental sustainability, social sustainability, and economic sustainability. If it's not economically sustainable, the enterprise is going to fail and go out of business, and that's going to be the end of it. So people tend to companies, any organization tends to think about the economic sustainability. What they don't think about necessarily is a social sustainability. So for example, if you are creating new jobs in one area, but you're eliminating jobs in another area, what happens if you go to scale? What's going to happen? What's going to be the societal impact, with those types of things? There's a lot of work that's been done, or at least a lot of awareness with respect to ethics and artificial intelligence, how AI can basically carry biases with it, that can really be prejudicial, that can cause lots of problems. And so engineers increasingly really need to think about the ethical implications, of what they do from that perspective. And then there's the environmental impact. And we will say, well, here's an electric car and it's zero emissions, but you had to make the car, and there was definitely emissions that were created when you're making the car. So, how do you trade between these things? And I think that's where the ethics comes in terms of how you make the trades between each of those. And there's a big movement now in environmental, social, and sort of governance, ESG, which companies are being looked at, and you need to have good ratings if you want people to invest in you. And I think that's the place where we can have the largest impact, that if we can create a means by which you can objectively rank and understand what companies are doing, what their impact is, that's going to help investors understand where to put their money. And that, in the capitalist society, I think, is the best way to change behavior. In the 80s, there was this pollution inventory that came out. They didn't change any rules, but the pollution inventory came out, and companies that polluted a lot quickly changed their ways just because it didn't look good. And I think that we can do the same sort of thing here, where we don't have to pass new laws, but if we can make these implications public, and we can do it in a way that's fairly objective, I think that we can change people's behaviors. But I think we can also make information available so that everybody can make decisions, I think, that are going to be more ethical and balance the social, the environmental, and the economic impact of what they do. So for example, I have an old car. It's a 2004 Volvo XC90. It's a great vehicle, still works great. It's a terrible gas guzzler. So what should I do? I don't drive very much, I could sell it, but I might sell it to somebody who drives in a lot, and that's going to have a big impact on the environment. I could junk it, but then I have to buy a new car, and a new car is going to have an impact on the environment. Or I could just keep it and keep my miles down as low as possible. And I don't really have a good sense of how to make those kinds of trades, but it would be great if I had an assistant that could sort of, give me those sorts of trades, so I could kind of make those types of decisions. And we make those kinds of decisions all the time, and we do it with very imperfect information. So what I'd like to do is to create the means by which engineers can have this kind of assistance through the design process, when they're designing systems, so that individuals can make those sorts of decisions, with respect to their consumption, and investors can make those decisions with respect to where their money's going to go, which can influence, the motion and the actions of corporations. So that's what I mean sort of by ethical sustainability. And it's really been a joy to teach people about it. We're creating a new program at UCSD. It's a specialization in cyber physical social systems. So we really care about social systems because, eventually that's where we want to have impact. We're not there to create technology, but we're there to have impact in people's lives and our society. And so ethical sustainability is built into this program, and we're going to create the tools and the methods and the processes and such so that people can make ethical decisions and trades throughout the design process.
When you were talking, Dr. Wade, the example you gave about your car kind of made me chuckle, because as you mentioned, you have those three choices. You can keep the car and try to keep the miles low, you can junk it, or you could buy a new car. And it just made me think that there are people out there that feel very strongly for each of those options. And if you and if you don't pick one, the option they feel so strongly about, they'll try to cancel you on Twitter.
Yeah, it's true, and so if you can get to the objective fact, then you may disagree, but at least you agree on the facts. And I think that's a real challenge that we have, is our society is bifurcating and we have separate realities. And so I think we've got a long way to go to get to the place where we're sort of back on the same page, at least with respect to what is reality.
Yeah, no question. So based on the career that you've had, I mean, you were able to describe ethical sustainability really well. So I suspect that you're able to do it not just on a podcast, but in other places too. So at some point you saw the benefit of being able to communicate well to others. When was that point when you saw that if I became a better communicator, this could be of use to me?
Well, I think the first time that I had to communicate was when I was an undergraduate and I had an internship, and I had to communicate my research results to a group of engineers. And so it was very technical. And I still remember the presentation, and it was with slides in those days where you had transparencies and you had to print those out and put them on, and project like that and everything. And I remember going through this presentation, and afterwards, they said, nice job and everything. And one of my friends said, you say the word basically or essentially before every sentence. And I said, well, basically, that's what, and I think it was this notion that, you can't just summarize information. You've got to tell a little bit more of a story, and there's different venues. I'd say my next big presentation was to sponsors when I was doing my research, but doing a doctoral defense is a big presentation, that you have to give, and it's one where it's really one where you're almost an attorney, where you've got to present your facts and you've got to have really well sort of structure to those facts so that you can withstand the different attacks and stuff. I think really where it started to make a difference for me was, after I graduated and I started taking on ever greater roles of responsibility, in the technical field. So as a manager, you might have a group of 10 or 20 people that you're talking to. And as a director, it might be 50 to 75 to 100. And then as a vice president, you've got over 1,000 people that you might be responsible for. And you've got to sort of, be able to present and motivate people in those groups. So it changes from being informational, which is, this is what we're doing to understand it, to motivating people, to change their behavior. And as you sort of rise the ranks in management, you're no longer directly connected to people, but you're indirectly connected to people. So you really don't have, direct control. So it becomes much more influential. So how do you influence people? And, the things that I've learned, simple things are, what if it's an influential type of a presentation, what are you trying to get people to do? And who is your audience? Those are sort of critical. But I sort of break it into three areas. There's sort of the ethos side of things, which is credibility. And I feel like you have to establish credibility, at the very beginning of every presentation. And you can do that in a number of different ways. It could be your expertise, it could be your background, but generally people want to know that you understand them, that you have some connection with them. And you may create that, credibility with a story or something up front that just makes you more human and somebody that people can relate to. There's the logos side of things, which is sort of the logical side. Engineers tend not to have a big problem with this, but they do have a problem with explaining things in ways that people can understand. Throwing up a page of equations, you may be provably correct, but nobody's going to understand you. Nobody might even believe you. And so you're not going to go very far that way. And then there's the pathos, the emotional side of things. And I've been told that, you really have to establish your credibility. You've got to have a logical argument, and you need to have some sort of an emotional close if you want to persuade people. And the fact is, they'll probably only remember the emotional close. And they may not even remember the words that you used. They'll just remember the feeling that they had, when they got to that place. And so I think that storytelling, understanding your audience, understand what you're trying to say, understand your audience, and having a story together that sort of reinforces each of those three areas, those are the most important things, I think, with respect to giving presentations where you're trying to influence people. Sometimes it's, excuse me?
Oh, please, go ahead.
Sometimes you're just trying to communicate information, and so you're just communicating information, and that's a pretty flat presentation. But if you want to influence, I think you have to use each of those three elements.
Dr. Wade, when you were talking about how people remember how you made them feel in the presentation as opposed to what you said, there was a previous guest who said that as well. And I remember thinking to myself, so I put all this time and effort into the presentation, and all you remember is how you feel. Well, damn it, I have a call to action. I need y'all to do something too. But you remember feelings. No, I was doing. Do you remember the doing?
It's true. The thing is that if you've got them to feel that way, it's going to be much easier when you do the next presentation or the next message comes out or the next whatever it is, be it an email or whatever else. People will resonate and pick up on that. And if it's a feeling, they may not even know why they're for it, but they're for it. And you can obviously use these skills for good or for bad. It's a neutral median. But hopefully people who are watching this podcast are doing it for the right thing, for the right reasons.
Yeah, and if not, at least keep it to yourself. So when it comes to presentations, at least before you give them, do you ever get nervous? And if so, how do you deal with your nerves?
It's funny. I think I'm always a little bit nervous, but I used to run cross country and track and those sorts of things, and I would get nervous before a race, and there was good nervous and there was bad nervous. Good nervous I think of as great because I'm keyed up, I'm ready to go. If I'm too flat, if I have no nerves whatsoever, that's concerning to me because I may not be present enough. I may not be putting enough into it. So that's an issue. Some people have really serious nerves where, I've heard that more people fear public speaking than fear death. I guess death is inevitable and public speaking isn't. But for me, it's just thinking about the people I'm talking to in the story and the desired outcome. it used to be, oh no, I got to give another presentation. This is horrible, and you start spending all this time fighting yourself. And for me, it got to a place where, oh, this is an opportunity for me to get the message out. And the more opportunities I have to get my message out, the better. But I think that's an individual road, and everybody's going to approach it, fairly differently. I remember I went skydiving when I was in my 20s. I was in graduate school, and for me, signing up for the dive was the scariest thing. And once I was on the plane, and these are back in the days where you went by yourself, it was a static line, so you just jumped alone. When I was on the plane, I didn't have any problem jumping because I'd already gone through the whole thing in my mind, and so I'd already taken care of that when I signed up for the course. So I think if you pre-visualize it, and you sort of go through that, the anxieties will be early, and then as you get into it, you're going to sort of go through what you've constructed in your head.
Yeah. You know what? I went skydiving in my 20s too, so we have that in common. And I also jumped out the plane solo. It didn't end up so good though, Dr. Wade.
Oh no?
No, I got all kinds of training beforehand. I thought I was good to go, and then I finally jumped out the plane. All that knowledge and the training just went out the window. I was just falling down to the ground, to the earth. Luckily, there was a trainer who jumped out right after me, probably saw that I didn't pull the cord when I was supposed to. So they pull up right beside me while I'm in the air and pull my cord for me. And I ended up landing somewhere like at least a mile away from where I was supposed to land. So people had to come find me. It was horrible.
Oh, wow.
Yeah. So that was the first and last time I ever went skydiving. I'll stick to the ground. If I'm in the air, I'm in a plane, and if I'm in the plane, I'm supposed to stay in the plane.
It's a perfectly good airplane, right? There's no reason to leave it.
No doubt. This has been really great talking to you, Dr. Wade. Thank you for taking time to be a guest. How can people get in touch with you?
They can reach me at my email address, which is jpwade@ucsd.edu. So jpwade@ucsd.edu.
Excellent. Well, everybody, that marks the end of another edition of Teach the Geek interviews. My name is Neil Thompson, founder of Teach the Geek. It's an online platform for science and engineering professionals. Consider checking it out at teachthegeek.com. Again, that's teachthegeek.com. Until next time, take care and stay safe. Thank you, Dr. Wade.
Thank you, Neil. It's been a pleasure.